Hello, Math 2 students. Today we are going to learn yet another way to prove that triangles are similar. The first way that we know to prove that triangles are similar is to use the definition of similarity. Pair up all of the corresponding angles and show that the corresponding angles are the same. And pair up the corresponding sides and show that all of those corresponding side ratios are the same. The next method that we use to show that triangles are similar is the SSS Similarity theorem. If we can show that two angles of one triangle are congruent to two angles of another triangle, then we know that those triangles are similar. Today, it's the SSS Similarity theorem and the SAS Similarity theorem. First, the side-side-side similarity theorem. If the ratios of the corresponding side lengths of two triangles are equivalent, then the triangles are similar. So we can show that triangles are similar without knowing the measures of any of the angles using the side-side-side similarity theorem. The next theorem that we're going to learn is the side-angle-side similarity theorem, and it says if an angle in one triangle is congruent to an angle in another triangle, and the sides of those angles form ratios that are equivalent, then the triangles are similar. So here's our first example. In this problem, we're going to verify that the triangles are similar and write a similarity statement. So in this problem, we know three sides in the blue triangle and three sides in the red triangle, but we don't know any angles. So in this problem, we're going to use the side-side-side similarity theorem. We're going to show that all of the pairs of corresponding sides are equivalent. So all of the fractions that we make out of the corresponding sides are going to be equal to each other. So we're going to start out, and I'm going to take the shortest side from the red triangle and the shortest side from the blue triangle, and I'm going to make a ratio. Then I'm going to take the medium-sized sides, 18 and 45, and make a ratio. Then I'm going to take the largest sides and form a ratio. And so I have these three ratios. If these ratios are equivalent, if they have the same value, then we know that these triangles are similar by the side-side-side similarity theorem. When I divide all of these fractions, all of them come out to 2.5. So all of these ratios are equivalent to each other, which proves that the blue triangle is similar to the red triangle. Our next task is to write a similarity statement. And when you write a similarity statement, you need to be sure that you list the corresponding sides and angles in corresponding positions in the similarity statement. To accomplish this, I'm going to name the angles in order from smallest to largest to make sure that I have the corresponding parts matched up in my similarity statement. So to start with, if I look at this triangle, the shortest side is 17, so the smallest angle has to be angle B. Now I know that that has to correspond to the smallest angle here. So the smallest side is 42.5, so the smallest angle has to be angle N. Over here, the medium-sized side is 18, so A is the medium-sized angle, and the medium-sized side is 45, so O is the medium-sized angle. And then the largest angle is across from the 30, that's angle C, and that corresponds to the angle that's across from 75, which is M. So one correct way to write the similarity statement for the red and blue triangles are triangle BAC is similar to triangle NOM. In this problem, they want us to find the value of x that makes triangle TRI similar to triangle ZAP. So there's two ways to start this problem. I can start with the sides that I know both values, which are the 4 and the 6. So I'm going to start with the ratio 4 over 6. And then I'm just going to pick another pair of sides, and I'm going to use 2x plus 6, which corresponds to 12. And I'm going to write that ratio. So that's one way that we can solve this problem. The other way to solve this problem is I'm going to start with the 4 and the 6 again because those are my known values. But instead of using 2x plus 6, which corresponds to 12, I'm going to use 10, which corresponds to 6x plus 9. Now I can solve either one of these problems and find the answer. So I don't need to do them both. I'm going to solve the problem on the left. In order to solve this problem, we need to find the cross product or cross multiply. But many students find it difficult or make a silly mistake when they're multiplying the 6 and the 2x plus 6, that monomial times a binomial. You need to do the distributive property. And if you forget to do the distributive property, you're not going to find the right value of x. So I'm going to start by multiplying 6 times 2x, which is 12x, and 6 times 6, which is 36. And then I'm going to multiply 4 times 12, which is 48. So instead of having an equation with a fraction on the left and a fraction on the right, now I have an equation, but on the left and the right, there are no fractions. So to solve this, I'm going to subtract 36 from both sides. And I get 12x equals 12. And then I'm going to divide both sides by 12. And 12 divided by 12 is 1x. And 12 divided by 12 is 1. So they're asking us to find the value of x that makes these two triangles similar to each other. And I think that that value is 1. Now we're going to check and make sure that 1 was the right answer by looking at all the ratios of all the sides. We're going to use the SSS Similarity theorem to make sure that 1 really does make these triangles similar. So I start out, and here are my two corresponding sides, 4 and 6. And then I have my two corresponding sides, 2x plus 6 and 12. And then I have my two corresponding sides, 10 and 6x plus 9. So I'm going to have 4 over 6, and then I'm going to have 2, not 2x, but now I know that x is 1, or I think that x is 1. So I have 2 times 1 plus 6 over 12, and then I have a 10, and instead of 6x plus 9, I'm going to write 6 times 1 plus 9. So now as I simplify those, I'll have 4 over 6, and then I'm going to have 2 plus 6 is 8 over 12, and then I'm going to have 10, and this is 6 plus 9 is 15. And if 1 really is the number that makes all of these ratios equivalent, then it is going to be similar. The two triangles will be similar. And so when I divide 4 over 6, it comes out to 0.6 repeating. 8 over 12 is 0.6 repeating. And 10 over 15 is 0.6 repeating. So when the value of x is 1, then all of these ratios are the same. So that means when the value of x is 1, we have two similar triangles. In this problem, they want us to sketch the triangles using the given description, then determine whether the two triangles can be similar. So I'm going to start out, I don't really know what triangle RST looks like, so I'm just going to draw a triangle, and I'm going to label it with an R and an S and a T, and then I'm going to draw a second triangle, and it looks like the numbers, the lengths of the sides are longer, so I'm going to make this one a little bigger, and I'm going to label it the same way. Since I put the R, which came first, at the top, I'm going to put the F at the top, and I'm going to put the G here, and I'm going to put the H here, and then I'm going to label the sides the way they say. So RS is 25, and then it says that ST is 30, and it says that angle S is 16 degrees. So there's one of my triangles, and now I have GH is 30, and HF is 36, and the angle that is in between is 24, that's angle H. So on this problem, I'm going to use the side angle side similarity theorem, which says if you have two angles that are equal, and the sides of those angles are making ratios that are the same, then these two triangles are similar. So to start out with, I'm going to check the ratios of the sides. So in this triangle, the shorter side is 25, and in this triangle, the shorter side is 30. So I'm going to write a ratio 30 over 25. And then in this triangle, the longer one is 30 and the longer one is 36. So since I'm going large over small, I'm going to put 36 over 30. And then if I change both of these into a decimal, that's going to be 1.2 and 1.2. So the side, when I match up 30 over 25 and when I match up 36 over 30, those are equivalent ratios. They both come out to 1.2. My problem is that the angle that's in between these sides is supposed to be equal if I can use the side angle side similarity theorem. So since 24 is not equal to 16, then these two triangles are not similar. All right, Math 2 students, after watching this video, I hope that you know how to use the side similarity theorem and the side angle side similarity theorem to prove that two triangles are similar. Thanks for watching.